I'm with the Citi Private Bank. I head data reporting and analytics for operations and technology. We're here to talk about some work we've been doing this year regarding demographics master data. We'll talk about the business domain, set some context. We'll talk a bit about the data domain, so what we're actually putting into the graph at a high level. Talk about the problem that we were trying to solve, the solution that we arrived at, some of the learnings that we had along the way, and then where we see the opportunities in what we've built moving forward. So for those of you who are not involved in the industry, let's explain private banking just a little bit. So private banking, broadly speaking, is an industry that provides a full range of financial services out to individuals who hold a certain range of wealth. This wealth can be classified from in the hundreds of thousands for what would be called a mass affluent customer, all the way up through the tens of millions to billions for what we would call the ultra high net worth client. This is pretty common across the industry, so these terms are fairly consistent regardless of what bank that you're talking about. Each bank tends to specialize in certain segments, certain sectors, but ultimately the consistent theme here is that with the amount of wealth that the individual holds, the amount of complexity regarding that individual, their relationship with the bank, and the things that they're doing tend to become equally complex. So you'll have a diverse range of locations, holdings of every asset type. The regulations start to look a lot more interesting because of those asset types and the number of locations that the clients tend to operate in. And then ultimately the clients themselves and their relationship with the bank become much more complicated. So starting with what we won't be talking about today, just diving a little bit into the types of assets that we tend to see, again, ranging from the basic retail checking account all the way up through subscriptions to sophisticated hedge funds and funds of funds, alternative investments, lending and financing for things like companies, sports teams, real estate, et cetera. All of this diverse business that we do with our clients, the servicing that we provide globally, so we operate out of multiple locations because our clients tend to do the same, brings a high level of complexity to the client. Now, we distinguish ourselves somewhat from, let's say, a retail context or an investment banking context in that we're not about volume per se. We are talking about a smaller group of individuals, so the real interesting aspect of doing technology in this context is not flow business like you might see in an equities environment, but the fact that we're solving very complicated problems for our clients. So let's talk a bit about the data domain. So again, some additional context. What we're really talking about is the party entity. So if you're a classic data modeler and data governance person, you talk in terms of entities, we're talking about the party. And parties are basically individuals, organizations, groups of organizations upon which you need to hold information. Now this information is contained in a more technical context into a master data system. So we take in information about our clients, employees, trust entities, companies, KYC related information. So not only do you hold the party, but ancillary data that surrounds that party. We aggregate that in a master data system, and then we distribute it to all of our downstream consumers, applications, end users, et cetera. Private banks tend to be, because they're multi-asset, have many upstream sources of information, whether they be custodians or external reference data sources or systems that reside in other divisions where you're handling assets on behalf of the client. So this information comes from multiple sources that we then have to aggregate, normalize, and persist for the purposes of doing business. This is not a radically unique concept. You see party entities and master data in any industry. But for every industry and every business, every company, every line of business, you will have variations on this theme depending upon the type of business that they do, the type of clients that they support. And now we're going to start talking about our problem. So in order to describe our problem, I think I need to explain a little bit about the private banking client. This is, again, not unique. Every company will have their variation. Every private bank will have their variation on this. But I think it's important to understand the private banking client, to understand what we're ultimately going to talk about, and that's how we put it into a graph database. So there's the client. I'm a client. You're a client. We're all clients. However, when we start to explain that in the private banking context, the client is, in fact, not just the client, but the client's spouse, their children, their grandchildren, and we start talking about multi-generational wealth. That's why the grandchild is important. So we're talking about the transference of wealth from one generation to another and the bank's involvement in that transfer. We're talking about supporting supporting cast of characters that surround that family, whether it's a legal entity that was set up, a trust that's held, the lawyers, the accountants, the money managers, family offices. It's a pretty broad list, and what you're seeing is the overly simplistic view. That's just on the client side. Now we start talking about the bank. And on the bank, you will have a banker. You can call it a banker, a relationship manager, an advisor, but you'll have a primary point of contact, the individual that is responsible for the relationship with the client. It doesn't end there. I have a banker, one, okay? For a private banking client, you also have an equally diverse set of individuals inside the bank that support that client. In a front office context, you've got trust officers. You have associate bankers or assistant bankers. Again, the semantics depend on what bank you're at, that support that client. You'll have investment consultants or product specialists. Again, the semantics differ depending on the bank, that provide advice, specialized advice on any given product that the client might want to engage in. Now let's continue with the middle and the back office. So we've got onboarding personnel that actually can bring the client into the bank, and then for all the products that the client wants to deal in, we'll open those accounts and maintain those accounts. You're going to have financing people that will open up loans and financing. You'll have regional managers that have to maintain the view across the entire business in a particular region. So the cast of characters starts to grow rather dramatically at some point. And again, this is a highly simplified view. And let's keep going. So these clients hold assets with the bank. So we have to represent the entities that hold those assets. We need to maintain groupings of those assets in order to portray, let's say, a portfolio of assets. And that ultimately you've got a range of ancillary data that supports all of this, like tax IDs, companies, employers, phone numbers, products, employee IDs, email addresses. The list is pretty broad. And what you end up with is something like this. Again, oversimplified, and for one client. Now, it's not like we haven't been doing master data in private banking for a long time, but we've been doing it in a relational model. And the relational model, given the many-to-many, and this is cliches and truisms about graph that you'll see marketed constantly, is that we're many-to-many. Well, in this instance, this is about as many-to-many as you get. You've got multiple multi-leg questions that you need to ask the data in order to just do business. And then ultimately, when you try to model this into a relational database, with those multi-legged questions, if you do relational databases, you'll talk about joins. Joins are expensive. That's why you talk about denormalized databases. So you either end up in a situation where you're correct and normalized, or you're denormalized and you have flattened data structures to support queries with sometimes thousands of temporary transient tables that you have to deal with. To a relational database person, that is not an ideal condition to be in. Because of this condition, fundamental changes to your data model are highly risky and highly costly in certain instances. So you end up in an accretive state. It's like a coral reef. Instead of making the fundamental changes to the database as your business evolves or your understanding evolves, you add tables to deal with the additional attributes and or entities that in theory, if you could rip it all up and start it all over again, would look different on that day two, on day two. Ultimately, the punchline is that it just simply cannot keep up with the business. And when new requirements come in, and in a banking context, a finance context, that change can come in the form of regulations. It can come in the form of even new types of products that come up. It can, and if your business goes from a strictly regional one to a global structure, these changes come quick, and you simply cannot change quickly enough to keep up with it. At least that is my experience. So what's the solution? And we'll start to now talk about a bit of what we've been up to for the past year. We are going live in October in production, so this might be a little premature for a victory lap, but it's gone well so far. We've been working on putting together a new system, brand new system. We decided to start from scratch, based on graph, to persist and distribute this type of information. I'm going to talk a little context. We are doing a pretty broad transformation of data in CPB today. This is not the only thing that's going on in my space. And what we're really doing is looking to take a golden source approach, make sure it's performant, make sure it's reliable, and make sure that it supports the entire range of products and services that we have to deal with. It's a rather ambitious statement to make, but I think that we've got a shot at pulling it off. Some key concepts that are consistent across all the aspects of what it is that we're trying to do here, and that translate right into this demographics database, master database, is certain principles that are fundamental. Separate your data domains in separate repositories so you can handle them appropriately. So we're separating the demographics related information from our financial information, so that way we have an opportunity to choose the right tool for the right problem. We're looking to make sure that we support all the regulations and compliance and risk concerns that we have in a banking context, of which there are many. And so we're going to be obfuscating all of the information that goes into the data, into the database, the data at rest. So we're tokenizing, so that way we're more free to use it when and how we want to, and still adhere to those regulations. As a global bank, we have global clients. We do have to worry about cross-border, so this is a fundamental concern. And that ultimately we'll want to move from certain preconceived notions about how we represent our clients in our database, of how we represent individuals in our database, and take a role-based approach. It's very important because there's a lot of business rule driving what it is that we're doing, and we need to make sure that those business rules can be clearly described, and that when we answer a question, we understand why. We do have a multi-year journey ahead of us. So there is a demand to synchronize with our legacy flow. Since they're going to have to coexist for some time, we've got to be able to take information that's being instantiated in the old flow and bring it into the new flow or the new database until such time as all of that has been redirected to the new system. So we are using techniques to synchronize the data from one database to the other, whilst making sure that that once it sits inside this new structure, that we are representing it correctly, rather than simply reproducing what sits inside the relational model. We are multi-channel. So at the end of the day, whether it sits inside of Neo4j or it sits inside of HBase or any other database technology, the consumption of that data will be driven by what the consumers actually need. So we will have RESTful services, we will have Kafka messages, we will have distributed object caches. The consumption will be appropriate to the consumer. One key aspect of this is getting applications onto the system. So we are building it out according to other transformational programs that will trigger the build out of the plumbing. And so it is function focused. It is not build it in isolation and they will come. It is we have a problem to solve and here's how we're going to do it. This demographics information, when we made the call on where to put it, as I said, couldn't be more tailor-made to a graph structure. And so we are building out this system. It is global, so it will be in every region that we operate in. It will take in every bit of client information that we take in and distribute, and that ultimately it will represent at a physical structure all of the business logic, business rules that one might want to ask all the way down to the physical structure. And this is why it was so appealing, is that my business rule is hardwired into my data at the end of the day. And since these rules are so complex, that's highly beneficial to us as a business. In order to explain the solution, we're going to go through some use cases. And I think that rather than going through the entire data model, which wouldn't be so helpful, explain every single question that one might be able to ask of the graph, which would be impossible, we'll focus on one that's representative of the types of questions that we in Private Bank need to ask of our demographics data. Prime example is a concept called visibility. If you've been in a wealth management or a private bank, you might have heard this term. It's actually not that uncommon. And visibility as a concept is ultimately, what is the scope of clients and accounts and other data of which I should have interest in? It's almost a superset of entitlements. So it doesn't talk about traditional entitlements topics in, I have a resource, I have a role, and I have an action, the common triple in an entitlements rule. It is more, as an individual, I should be concerned with this range of information. And so the business rule then comes into play. We have taken a role-based approach, meaning who am I, where am I, what function am I serving, and what interests do I have? And we will walk from role to role to explain how that rule is manifested at a data level and what answer it's providing. So let's start with the banker or the advisor. The banker obviously has fundamental interest in the clients for which they do business, right? I am a lead banker for this individual or group of individuals. These individuals are clustered, at least in our context, in a relationship. And so obviously for all clients for which I am lead banker, I have access to these relationships and subsequently these accounts. It's a fairly direct line. Now, that's a simple condition. However, we operate in an organization. So those lead bankers in turn roll up to a regional manager. Now that regional manager by definition should have access to all of the business that the bankers in his region do, which means that I'm now hierarchical. I'm a regional manager. I have these clients that report to me, and subsequently I have access to the client's relationships accounts for which they're responsible. So we've already built a graph. You can see it in crayon up on the screen. Let's continue with the roles that we talked about previously. We've got the associate banker. The associate banker, I am an associate banker. I support this lead banker and this lead banker, who in turn is lead banker for these relationships and clients. We have lead bankers where they operate in multiple regions. So we end up with relationships going across regions. And so we need to establish those relationships because by definition of the support that I'm giving to a banker in another region, I should have access to those clients and accounts. And then we have roles who have broad access to information. So it's not strictly about the client, it's actually about, let's say, the region. So I'm an operations person, I am a KYC, QA person, I'm an onboarding person. Because I'm supporting an entire region, that relationship is established not through the individual client, but by the region that I'm supporting. Now, in previous incarnations, we might have just simply assigned a certain class of visibility to an individual. Here, it's modeled into the graph. The visibility question is being asked starting at the region rather than the client. The direct link is not put in place between that individual and every single client in the region. Because of the business rule, I am an operations person and I am in this region. You walk the graph starting at the region and then work your way to the clients. So again, the structure represents the business rule. So that is a brief overview of what we're actually dropping into the graph and how the business rules manifest themselves. There are other questions that one might need to ask. Relationships with public figures is a good example. Which public figures are related to which public figures? We'll go more into that in the opportunities. But there are certain questions that when we dropped them into the graph structure, we were able to answer without ever really intending to do so from the onset, which was a remarkable thing to do. It wasn't a requirement. No one asked us to put that in place. But just because of the graph structure, we were able to answer them. Bit more about the solution. So all of this data that we're putting into the master database, it is, as I said, global. So we're building out clusters of Neo4j in multiple regions in order to support the requests that those graphs are receiving. So one of the important things to note about what we're doing here is that the intent was to always ask the question directly to the graph, rather than having a cached version of it, because there are certain questions that you might want to ask that are pretty straightforward to structure in Cypher. Might be a little bit more difficult to create an object, get into a bit of Java code, create an object, make sure that the object has all the necessary attributes, and then push that code out to then push those objects out into your distributed cache structure. So upfront requirement was always ask the graph first. Because we will have things like latency issues, meaning I have an application whose service has been spun up over in region A, the business application. We want to make sure that the data is close to it, because the alternative, if I go to a central source, is hundreds of milliseconds of latency. And so we are just pushing this, the graph databases out globally and making certain that that data is globally consistent. The only reason that we can do that is because we are setting the bar at the highest point possible when satisfying things like personally identifiable information, PII, cross-border, privacy regulations. We basically pick the most stringent of those regulations and set the bar there. And then we tokenize that information to make sure that it is non-identifying, which means that we can have a globally consistent graph. That's important because the balkanization of the information is highly complicated to maintain. If I have different representations in different locations of my master data, the time and energy that goes into synchronizing what should be synchronized, leaving local what should be local, in the end, those rules end up being almost impossible to understand. And so the intent here is make it consistent, keep it simple. Make the decision on what one can see at the point of consumption. And this is also a common approach, not just to graph, but reveal at the last mile. And so if you go into many private banks, they will stitch in that identifying information when they render the report, when they paint the screen, to make certain that it is not available until the last possible moment when you know who you're talking to and why they want access to the data, and then you make the determination of whether they should have it to begin with. Sitting up underneath this is that once we've got the information tokenized at the point of consumption, if we receive it from a custodian or we have an onboarding application that's operating out of the region, we push that out over Kafka. It's just a choice that we made. And then that data is sent out to all of the databases the clusters that reside globally. When the user opens the screen, if it is appropriate, at that point we will detokenize and they'll have access to the information. We already talked about the separation of demographics and financial data. It's in the solution, it is important to touch on it briefly in that we'll have a repository of financial data here. We'll have our party master over here. Even the financial data has identifying information in it. At the bare minimum, you'll have, let's say, an account number, just to start. That will also be tokenized as well. And then there will be a link with globally unique identifiers with the tokenized ID itself, so that when, let's say, I want to put a portfolio viewer up onto the screen with a list of transactions, ultimately, we will be able to identify which transactions are associated with which accounts based upon the token that we put into the graph and then the detokenization that occurs once we need to paint that screen. Other aspects of the solution. So we're putting this in line with business critical functions. This is not some offline analytics tool that if it goes down, no one will notice. When an individual opens a web browser, brings up, let's say, the client portal, it will be performing a visibility check at that time. So if that service is not available, we've immediately got impact. And so what we're trying to be very careful in doing is making certain that the solution is actually enterprise ready. The solution is business critical adequate. And so we've been going through a round of performance testing, both on reads and writes. A non-functional requirement going into this was if I do a query, user better not notice. So response time should be between 100 milliseconds, 300 milliseconds, depending upon which bar you're using, or under. So that was a requirement. We're going to have write requirements where we are synchronizing from our Oracle database changes that take place that the new applications are not responsible for. And that write condition is important because we do morning batch. Batch is still a thing. And if I've got, a few 100,000 updates that I need to make, it should probably complete before the batch cycle is done, rather than a day later, which depending upon your write performance, that could be a factor. We've also been very careful in the resiliency, and so we have come up with approaches to the failover, both locally, in data center, between data centers, across regions. The good news is that since it's globally consistent, I've in essence going to have instances in every single region. We should be pretty reliable. If you lose an entire data center, you can still get an answer. You might have to wait a few hundred milliseconds to get it, but ultimately the system, because we've gone to the trouble of making sure that it's consistent, will also be pretty available. But we also have to deal with COB and your typical failover conditions, and that's being designed into it. And then finally, if you've ever worked at a bank, getting new technology can sometimes be rather interesting because banks have to worry about regulators and auditors and compliance people. Info security is a big thing. We've all seen the news items on data loss and data leakage. They make pretty certain that the solutions that we bring into the bank satisfy those, and so it's gone under months of certification actions to make sure that info security understands and accepts the way that Neo4j is set up. That compliance, ultimately we're interacting a lot with compliance and legal to make sure that they understand the solutions that we're bringing in and that agree with the approaches. So we've done our due diligence. I hope some of my partners are actually here in the audience and getting these certifications done. And at the end of the day, we're rather optimistic that we've done what we need to do to make sure that it's an enterprise-ready solution. So roughly speaking, that's what we've been up to for the past few months. Now, it's been a journey. Not my first interaction with Graph, but certainly never to this level of detail, not so directly. The same with my team. So we've had a lot of learnings along the way that might or might not be interesting. So first one, don't do lift and shift modeling. Right? Don't go into your relational database and try to shove it into a graph structure. It won't work. So you have to discard a lot of preconceived notions. So take that fresh look and step back, and it will go straight into the business concepts. It's not just about the technology or the coding. It actually does cause you to take a new look at even certain assumptions from a business context that need to be revisited. And that ultimately, because you're going back to the original business concepts, you had better do this in close partnership with your business. If I'm going to talk about, let's say, the role-based visibility as being an example, that's not how we were really doing it before. We had a solution that worked at the time, and it was one that worked, but now we're taking a fresh look at that and saying, okay, the business rule is actually key here. So what is that business condition? Who are you? Why are you asking for access? And can I represent that in the form of a business rule? If I can represent it in the form of a business rule, that means that more likely than not, I can model in my graph. Okay. Other things that we ran into, Graph actually helped us expose certain data issues. Deduping becomes a big thing in Graph. Just a perfect example of this was employer. So if you go into it with an idealistic hat on, you just want one representation of, let's say, a company. So employer is a KYC question that one needs to ask. Who are you employed by? Now, the minute you ask that question, you start thinking company. Now, before, it was thought of as an attribute. Doesn't necessarily need the same kind of controls, because that ultimately is just a field in a KYC workflow, and I just need to capture that. You step into the graph world and you start asking that question, do I have a single representation of that actual company? Because there'll be questions down the road, post the first round of work that you're doing, that might be very interesting, and you will want one representation of that sitting inside of your graph. And so we go from, I can call it Citibank, Citigroup. Actually, had to answer that question when I walked in, who do you work for? You want one example of that, and that is Citigroup, let's say. And that will require a lot of data cleansing, and then we'll also have to go back, since we're operating in parallel, and correct the validations that are performed in the older applications that aren't even talking to my graph to make sure that they don't dirty it all over again. Data governance. If you do data, this should be a topic. We ultimately are incorporating heightened data governance. We do data governance today. We have a CDO. We talk to CDO, and we do monitoring. But ultimately, we're looking to ramp up the amount of governance that we have. And we're doing that from the beginning. Rather than building the platform and going back and backing into governance, we're starting from the beginning. And any entity that goes into the new repository, by definition, has to be governed. And so it has raised certain, I'm not going to say contradictions, but there are certain nuances to dealing with this in a graph structure that in any new technology, that you have to go back to the old assumptions in data governance and maybe revisit them as well. So things like key data entities, critical data elements, what is an owner, what is a steward? When you're talking about a Kafka message or an object that's in a cache or a graph database, you need to bring what was understood as a traditional governance process and bring it into this new world. So you can understand, I have a logical data entity, classic logical data entity. How do I map that to my physical structure when it is blown out in a graph? And that my one entity that might have 200 attributes is now 30 nodes with a couple of properties and a bunch of relationships that actually don't even fit into that original logical data model that looks like a table. So ultimately what we've done is that we're bringing the dialogue back. Data governance people start talking at the very beginning, pre-implementation. As we go through that process, the person on my team that's responsible for governance is talking frequently with the folks that are actually implementing the graph structure and trying to understand what the connection is. And this will just be an ongoing process, but the dialogue has to be very active. I won't be able to go through these in detail because I think I might be running out of time here. So it's a new product. Like any new product, it's got nuances. Just because, graph doesn't just work. We've been spending a lot of time on performance, and certain issues that are universal, doesn't matter what the database structure is, performance optimization, tuning. Indexes are a thing. When do you index and when don't you? We learn certain things like, full leaf scans are bad. I've got to hurry up here. Order by, now I've got order by as a problem here, but I'm told that this has actually been fixed in version 3.5, which we are eagerly awaiting to download and give it a shot. But order by and anything before 3.5, really painful. And that the data structure itself, you got to reduce the complexity. So if you can drop an edge that will actually improve the performance of the call, then drop the edge. This is something that can and should be done. You can go from an ideal graph to a practical graph, and it's actually not a bad thing. I'll skip right past this. And finally, where is this all going? Ultimately, we want to turn our data from a cost to an asset, actually provide value. That use case I mentioned before about the public figure, again, it was a happy byproduct. I can tell you which public figure is related to which public figure through its relationship with our bank, zero cost in that. And it was a question you simply cannot answer in the relational structure. Once we bring domain-driven graphs, so that if you've had that conversation on domain graphs, once we bring the domain graph topic into play, then we'll have things like, I've got my demographics master data, I also have prospecting information. And if you go with those unique identifiers, you go with unique nodes, I can link my prospecting data to my demographics master data, and immediately you're exposing value. I've got clients and bankers in this location. I have potential prospects working at the same company in the same location that participate in this philanthropic organization. It starts to get really interesting. And it's not hard, well, it's easier to accomplish than if you were trying to do this, again, in an Oracle, let's say an Oracle database, a relational database. They have their place, relational going nowhere. But for this type of problem, graph really helps. Oversight's the other thing. Again, we're a bank doing AML, anti-money laundering, doing KYC, doing suitability. You probably will see AML as a case around here. People talk about that quite frequently with graph, and it is super powerful. So while I might not put my transactions in that database to calculate performance, putting transactional type information into, let's say, a domain graph to answer AML questions is actually a really significant approach to solving a problem. And I'm done.